So we've got this final question here then, the infamous snooker table question from 2023. Remember, loads of students talking about it after the exam, lots of horror stories. But most of the question isn't that bad. It looks scarier than it actually is. Okay, most of the question is going to be, again, the same sort of standard stuff, right? So let's have a read. So we're told a small, smooth snooker ball is projected from a corner A on a horizontal rectangular snooker table ABCD. Okay. Basically, we're given all the information on the diagram again. So let's jump into it. So it's given us this big diagram here, which basically shows all the collisions going on. Okay. So we're told where do we start? We start at the corner A. Okay, it's projected from the corner A. Okay, so we start from A and then we head towards this point here. So this point P is my first collision there. So hopefully happy with that. Now, so my first collision. And again, I'm going to just do the parallel and the perpendicular components. So it wants me to show firstly that tan beta is E1 tan alpha. Okay, again, it looks a bit scary, sort of a random thing to get right. But I'm just going to do the standard stuff. So my first collision. So this is my initial speed U. Hopefully you can see that right. So if I split it up, I'm going to go up here and then across there. Okay, so this is going to be U sine alpha because it's again opposite the angle alpha there, and then up here it's going to be U cos alpha, right? And then if I resolve the speed afterwards, V here, we're going to go across here, which is going to be V cos beta here, right? And then down then by V sine beta. Okay, if I could squeeze it in there. V sine beta there. Okay. Alright, so hopefully happy with my components there. Okay. So there we are. So I've just split up the two speeds here. So U and V, my before and after speeds, I'll split them up in this way. Okay, so hopefully happy with that. Okay, so again, let's get cracking. So I've got my parallel components first. So okay, parallel to, well, it's going to be this wall here then. These are my parallel components. So V cos beta is going to be U cos alpha, and then perpendicular. So it's going to be perpendicular to the to that wall. So it's going to be these two components here. Hopefully you can see that right. So that's going to be V sine beta is going to be E lots of U sine alpha. Okay, hopefully happy that these are just, again, all we're doing here is the standard stuff of finding of doing the parallel and the perpendicular equations. Okay, so hopefully you should be happy with what I've done here. Okay, and actually more specifically, the coefficient of restitution is E1 here. Okay, that's for the first collision, so it's actually E1 here. And so okay, I could if I call this equation 1 and 2 then well, we could square them to get the speed, but I won't be able to do that really because I've got E. Okay, so I won't be able to get the speed. But also, the question just involves tan. Now, how can we get tan of the angles? Well, we divide the equations, don't we? Right. So if we now just divide them, then if I divide the two equations, I get V sine beta over V cos beta to be E1 U sine alpha over U cos alpha. And then quite nicely, you'll see that I will get tan beta on the left to be E1 tan alpha. And again, the V and U's will cancel. And there we are. We've got the first equation there for 4 marks. So there we are. So again, pretty standard procedure. It looks ugly, but hopefully you can see I've done nothing out the ordinary to this point, right? Then for part B, so it says show that now E1 tan alpha is E2 cot gamma. Okay. So gamma is over here. So this is now the second collision. So now I'm going to need to consider the second collision, right? So if I look at the second collision now, which again is happening at the point Q here, well, I've already got my components for V, and then afterwards the speed is W. So W is going to go down here, then across here. Okay, so hopefully happy with that. So this is going to be W cos gamma. Yeah, there we are. And then W sine gamma. Okay, again, because it's opposite, it's facing the angle gamma there. So hopefully happy with my components for the speed W there. Okay, and so there we are. So so that's my before and after speed. So if I now do the parallel equation, so what's parallel to the wall here? It's going to be these two components, right? So W cos gamma is going to be V sine beta, and then perpendicular. So then the perpendicular components are going to be here and here, right? Hopefully you can hopefully happy with that. So that's going to be W sine y, and that's a gamma. Mine looks like a Y. I can't draw gammas very well. So W sine gamma is V cos beta. Oh, sorry, E lots of V cos beta, right? Because E acts perpendicular. And actually, it's going to be E2. Okay, the second wall is E2 for the coefficient restitution there. And so again, I got my two equations again, right? So if I call these equations 3 and 4, well, actually, then we're going to do the same sort of thing, because again, it wants me to show again tan and stuff like that. So I'm going to need to do the same procedure of dividing the two equations. So if I divide the 4 divided by 3, divide the bottom one divided by the top one. So that's going to be W sine gamma over W cos gamma. It's going to be E2V cos beta over V sine beta. And so this will simplify to tan gamma is going to be E2. The V's will cancel. Then we're going to get cos over sine beta. Okay. And so then notice that, well, we have cos over sine. So actually, it's going to be the reciprocal tan, right? Because tan is sine over cos. So if we're doing cos over sine, that's then going to get me 1 over tan. Okay. So 1 over tan beta there. Okay. Hopefully you're happy with that, right? So we can simplify to tan gamma is E2 over tan beta there. And there we are. So there we are. So again, hopefully you're happy and you're with me here, right? All I've done up to this point is just standard procedure, right? So all I've done really is just gather my parallel and perpendicular equations, and then I divided them, right, to find the angle, to find tan, right? Which I've been doing this whole topic, okay? I've been doing the exact same stuff this whole topic with like every question. So hopefully you're happy here, right? Again, there's a bit of a trig, loads of letters, but hopefully you're with me here, and hopefully you understand the steps, right? I've done nothing out the ordinary so far, right? Hopefully you're comfortable and you're happy with me here. Now, if I now look at the question, Well, it wants me to show that E1 tan alpha is E2 cot gamma. Now, by the way, cot is 1 over tan. Okay, you need to know that from normal math. Okay, but ignore that for a second. What's the key difference between their expression and my one? Hopefully you notice I have tan beta, but in their expression they have tan alpha. So I need to somehow get rid of beta and turn it into alpha. Okay. But actually, I know from the first collision we deduced, and from the first equation, in fact, that tan beta is, from the first part, sorry, they want to be shown that tan beta is E1 tan alpha. Well, there we go. We have an expression with tan beta. So I can sub that in here. So I'm going to say, and tan beta is E1 tan alpha. So tan gamma then, if I substitute it into here then, I get tan gamma to be E2 lots of E1 tan alpha. And there we are, right? There we are. Okay. And so actually we're pretty much there, right? Now, okay. I guess let me get rid of the fraction for now. If I times across, okay, that's going to be E1 tan alpha tan gamma to be E2, okay? And so, if I now look at what they want me to show, well, what's the key difference now? Again, they have cot gamma, okay, in their expression. I have tan gamma. So remember cot again. Cot is 1 over tan. So actually, if I divide by tan gamma, I'm going to get that E1 tan alpha. It's going to be E2 over tan gamma. And so therefore, E1 tan alpha is going to be E2. And then 1 over tan gamma is indeed cot gamma by definition. And that is now the expression they wanted, okay? So this is where the challenging part of the question really comes into play here. So now I'm told for part C, by considering the angle of APQ and the angle of AQP, or otherwise, show that it'd be possible for the ball to return back to A only if E2 is greater than E1. Okay, and now they've actually, well, nicely, I guess, they've given us a starting point to work with. So we need to consider these two angles, okay? So angle APQ and angle AQP. So let's just look at my diagram and mark them, right? So firstly, angle APQ is going to be here, right? I'll call it little p. I'll call it little p to represent at the point P, right? So that's angle APQ, right? And then AQP, well, it's going to be the angle here at Q. So I'm going to call it little q. Okay. So there we are. So, okay. So, again, if you look at the question then, it wants me to consider adding these two angles together. So I'm going to need to sort of find expressions for for angles P and Q here. Well, actually, look at where the angles are. They're at points P and Q. Well, look. Hopefully you can see here at P that all these angles are on a line. So all the angles here, alpha and P and beta, have to add up to 180, right? So there we are. So therefore I could say that firstly, for angle APQ, so that's going to be 180 has to equal the angles alpha and P and beta, right? Therefore, therefore P then, the angle APQP, if I rearrange, I'm just going to get 180 take away alpha, take away beta, right? And there we are. So that's the first angle. Then I'm going to find a similar expression for the angle AQP, right? So now if I look at angle AQP, well, so it's going to be this angle here, right? Q. Well, again, I got the same sort of situation where we've got angles on the line, but we're missing this angle here. But actually notice I have a right angle triangle here, right? So I have angle beta here, I have a 90-degree angle. So this angle here, well, it's going to just be 90 take away beta, right? Because all three angles have to add 180. So 180 take away 90 here, that'd be 90. Then I'll take away another beta. So 90 take away beta for the angle there. Hopefully happy with that. Okay, so that's 90 take away beta. And now we're in a situation where all these three angles again are on a straight line. So 180 has to be 90 take away beta, add Q, add gamma. Okay, hopefully with me here. So then again, 180 has to be 90 take away beta, add Q, add gamma, right? And so then if I rearrange for Q, hopefully you can see that Q is going to be 90, add beta, take away gamma, right? And there we are. There we are. So those are those two angles then. Okay. Now the question wants me to consider, if you look at the question, it wants me to add these two angles. So now let's do just that, right? Okay. So remember these two angles are called P and Q. So let's consider adding P and Q. Okay. So literally, if I just bring these two expressions together, P and Q, well, that's going to be 180. Take away alpha, take away beta, then add on 90, add beta, take away gamma. Hope you're happy with that. Then if we simplify this, we're going to get 270. The betas will cancel, so we just got 270, take away alpha, take away gamma. And there we are. Okay, so those are those two angles combined. It doesn't look particularly useful, striking what we can do with this. So let's have a further look then. So this is where it gets really challenging now, right? Where do we go from here? And I would say, I believe you'd get 2 marks, right, for getting to this point, for deducing what these two angles make. So again, the question does kind of tell you to start to do that. So again, you're really only losing 4 marks from here, right? So I guess it might not be the end of the world if you're struggling to see what you can do now. Again, hopefully happy with this of what I've done up to here, right? So again, what we have done is just found these two angles together, but hopefully you can see they are in this sort of triangle we've got here, right? So actually, if we found 2 of the angles, it strikes to me that maybe we need to find something for this angle here then, theta, because we know angles in a triangle have to add up 180. So now I can therefore take 180 away from P and Q to get the remaining angle theta in this triangle here, right? So what we can say is therefore theta, I'm going to say theta is angle PAQ, I believe. Okay. But the angle theta then is going to be 180, take away the other two angles in our triangle. So it's going to be 180 take away P and if I factorize this, okay, take away P and Q. So it's going to be 180 take away 270, take away alpha, take away gamma, right? So if I simplify this, I'm going to get alpha add gamma take away 90. Okay, and there we are. So how can I use that then? Okay. Right. Now this is where you need to have a bit of a brainwave, a bit of a eureka moment, okay? Because what we are saying is we want the ball to return back to A, right? If we want the ball to return back to where it started. Well, in other words, we basically want this triangle to exist, right? We want to create this triangle. If we create this triangle, as we just established, If we create the triangle, then it will go back to A. So the triangle does have to exist, which might sound a bit basic, right? But if the triangle was to exist, then the angles have to exist, right? So as we know, all the angles have to be between 0 and 180, right? In order for the angles to exist, right? Because obviously angles in a triangle have to add up to 180, so between 0 and 180. If the angles exist, then we get our triangle, right? So we basically need to say that theta has to be between 0 and 180, right? Because then there'll be an angle that generates at A. So then it will reach back to A and then it will have the triangle. And that is what you need to think, right? Somehow you need to pluck that eureka moment there, okay? That's going to help us now. So theta needs to be between 0 and 180. For the ball to return back to A. And form the angle in the triangle. Okay. And there we are. That is probably the most complicated thing that students tripped up on is trying to think of this inequality, right? It might seem a bit too basic, like might seem like, oh, well, obviously it's between 0 and 180 in a triangle, but that's what you need to work with, right? So it's between 0 and 180, but then we could sub out expression in. So therefore 0 is between alpha add gamma minus 90 and then 180, right? So what we can then do, I guess, is sort of rearrange for one of them, right? So we might then rearrange for gamma, right? So if I add 90 to the inequality, so I'm solving for gamma pretty much, right? So then I'm going to get 90 is going to be alpha add gamma and then 270, right? And so then if I then take away alpha, that tells me that 90 take away alpha is between gamma and between 270 take away alpha. Right, so how does that help me? So it tells me, if I break the inequality up, that firstly, gamma is bigger than 90 take away alpha, and gamma is less than 270 take away alpha, okay? Right, so I've got these two inequalities then, and essentially then I've got gamma in terms of alpha, pretty much, right? And so, at that point, okay, I'm not entirely sure how to proceed, so let's just revisit what the question's telling me, right? So we need to show that E2 is greater than E1, okay? Now, so how am I going to get that? How am I going to link E2 and E1 together? Well, then if I look previously, I've shown this equation here, right? I have E1 tan alpha is E2 cot gamma. Well, that involves E2 and E1, and hang on, don't I have an inequality I've just got linking gamma and alpha, right? So if I got gamma and alpha as an inequality, then I can somehow get E1 and E2 as an inequality. So I'm going to need to use this equation, right? That's what's staring at me to do, right? Because it involves alpha, gamma, E1 and E2, right? So let me just write down that equation. So we have E1 tan alpha is E2 cot gamma, right? So as I just discussed then, I got these inequalities, right, linking gamma and alpha, but I want tan alpha and cot gamma, right? So if I want tans, right, so I want tan alpha. Now remember, cot is also tan, right, because it's just 1 over tan. So I need to consider tan of both the angles alpha and gamma, right? Hopefully you're with me here, right? That's probably what's sensible to do. Because if I got the angles, then I need to do tan of the angles, because that's what the formula involves, right? So, what I can do then, again, this is where you kind of need to have like a second brainwave, if this question's not hard enough, is you then need to say, well, we can effectively take tans on both sides. So we can deduce for this inequality here, that tan gamma is greater than, tan of 90 take away alpha, okay? Now, again, a lot of caution is needed there, but what I'm doing here is I'm doing the standard technique that I discussed at the start of this section, right? So remember when we said that if we had tan x was tan of 90 take away y, right? When we looked at this is one of the common techniques we saw. We can deduce specifically when x and y is less than 90 that then x is just 90 take away y. So we can equate the angles. That works, and actually we can do it in reverse. Okay, so in this case, if we have gamma greater than 90 minus alpha, then tan of gamma would then be greater than tan of 90 minus alpha. We can do this process, right? We can do this common technique here. And again, to convince yourself that we can do this, gamma and alpha are less than 90 degrees, because if we look at our diagram, right? Okay, so this is gamma, right? Now, this is in a right angle triangle, but we already have 90 degrees. So that means gamma has to be less than 90. Because if one angle is 90 degrees, then that forces the other angles to be less than 90 to get 180 overall. Exact same story for alpha over here. Because there's already a 90 degree angle in the triangle. So that forces alpha to be less than 90, right? So yes, indeed, we can do that technique because alpha and gamma are less than 90. If you want, you could add a little justification there. So when we jump to doing tan of the angles, I'm going to say that's because both gamma and alpha are less than 90, which allows us to employ this technique here, where we can do tan of the angles. Okay. So there we are. So have that sort of technique in your mind, right? But yeah, very nasty thing for you to sort of try and think of to do, right? Anyway, so hopefully you're happy with that, right? So tan of gamma is greater than tan of 90 minus alpha. Now, again, make sure you only do this with tan. If he was to do it with cot instead, and you sort of took cot of both sides, which you might think to do because we have cot gamma, right? That inequality would not be true. Actually, it'd be reversed. But actually, it wouldn't work in the way you think it would. So the best thing to do is just do tan, right? Anyway, so tan of gamma is greater than tan of 90 minus alpha, okay? And by the way, the mark scheme doesn't expect any justification. It just jumps to this step anyway. But yeah, okay, right. And actually, the question just follows quite nicely after this point, right? So at that point, we're just going to be doing some trig to simplify, right? Anyway, so we've got to this point here, right? So we gathered that gamma is greater than 90 minus alpha. Then we just took tan of both sides effectively, right? Now, okay, well, we have tan gamma and we have tan 90 minus alpha. Okay, so what we need to do, well, actually, I'm thinking I need to expand this compound angle for tan, right? So let's see what that simplifies to. Okay, again, we also looked at this in the common techniques. So tan of 90 minus alpha. So I'm going to need to use the compound angle formulas in the formula book, which you should have seen in normal maths pure year 2. Okay, so we've got these here. Now you might be tempted. We want to find tan of 90 minus alpha. Well, you might be tempted to directly use the tan addition formula. If he was to do that, right? what you would get, if I was to use that formula, you would have tan 90 plus tan alpha over 1 minus tan 90 tan alpha. Okay. Okay, so that's when you use the formula for tan, for the compound angle formula for tan, to sort of expand this expression. But you can see the issue here. We're going to need to evaluate tan 90, which is undefined. But don't panic, we can get around that, because we can alternatively say that tan of 90 minus alpha is just going to be sine of 90 minus alpha over cos, right? And then we can use the sine and cos compound angle formulas there to expand the sine and cos of 90 minus alpha, and that will simplify. So I'm going to do that now then, down here, right? So I'm just using the standard compound angle formulas to simplify this expression here. So this is the same as 90 minus sine of 90 minus alpha over cos of 90 minus alpha. Now, if he was to expand that, again, the compound angle formula, the addition formula, whatever you want to call it, okay, if you want to use the formula book, if he was to do that, hopefully you're convinced that this will go to sine 90 cos alpha, take away cos 90 sine alpha. And then for cos, if we were to expand this, we'll get cos 90 cos alpha plus sine 90 sine alpha, right? So hopefully you're happy with that. And then we can evaluate sine and cos of 90. So that will simplify to cos alpha over sine alpha. Okay, and there we are. So and that is, what is that expression? It's going to be well, 1 over tan alpha, right, or cot alpha, whatever you want to call it. So therefore tan of 90 minus alpha is the exact same as 1 over tan alpha. Okay, right, so hopefully you're happy with that. And so then tan of 90 minus alpha is 1 over tan alpha. Well, then we can actually simplify this inequality here. So therefore we can say that tan gamma, well, it's going to be greater than tan of 90 minus alpha, but that's, as we just saw, the exact same as 1 over tan alpha. And so we can use that in this expression here. So at that point then we just need to do a bit of algebra to simplify it now. Remember, obviously we got cot gamma here, but here we have tan gamma. But literally remember that cot is just 1 over tan. Okay, so what we can say is that E1 tan alpha is just going to be E2 lots of 1 over tan gamma. Okay, so at that point it might be best to rearrange for just tan gamma, right? So if I now multiply this whole expression by tan gamma, I'm going to get E1 tan gamma tan alpha is E2. And then to get tan gamma on its own, then I can say that tan gamma, I'm going to divide by E1 tan alpha, right? So it's going to be E2 over E1 tan alpha. So hopefully happy with how I've got to this step here, right? And so at that point then you can see I'm in a position where I can very explicitly sort of substitute this inequality in, right? So that therefore means that if tan gamma, if tan gamma is greater than 1 over tan alpha, then if this expression is tan gamma, therefore E2 over E1 tan alpha has to be greater than 1 over tan alpha. Right? Hopefully happy with that. I'm just substituting that inequality in. And so if I now multiply both sides by tan alpha, I get E2 over E1 is greater than tan alpha over tan alpha, which just goes to 1. Okay. Now remember, you might be right to be cautious about what if I'm multiplying by a negative number. What about the inequality? But tan alpha is positive. Okay. That is because again, tan alpha is between 0 and 90. Think about the tan graph between 0 and 90. It's positive, isn't it? So tan alpha is going to be a positive number, a positive quantity. So don't panic about that, right? But even if you weren't sure, again, honestly, you can use the question, right? Because again, ultimately, we want E2 to be greater than E1. So if you get the wrong inequality, then the wrong direction of the inequality, then it'll tell you where you've gone wrong. But anyway. So, hopefully happy with that point, and then we got it. So just multiply by E1, we get E2 greater than E1, and there we are. Okay, so yeah, very nasty question that is. Right, so that's part C done. Okay, so very nasty question, right? Now, that was worth 6 marks. Well, actually, 2 of the marks were for just doing the finding these 2 angles, right? Which is what they told me in the question, right? So you would have got 2 marks just for following the question kind of explicitly, right? So hopefully that didn't cause too much trouble working out an expression for these 2 angles here. But yeah, the later part of that question is just horrid, right? A lot of things you just need to think to do, right? Which might be a bit difficult in exam situation, but there we are, right? Okay. Now, then I'm told if instead E1 is equal to E2, the ball would not return to A. And so now we're told to take E1 to be equal to E2. And then from part B, so I'm going to have to use this equation, right? Describe the path of the ball after it hits CB at Q. Okay, so after the second collision at Q, what does the direction look like? Okay, well, what path does it make? And again, that's also quite tricky, actually. It probably seemed really vague, right? But let me just play around with this, right? So if E1's equal to E2, and again, they asked me to use this equation, right? So that means E1 tan alpha is then going to be E1 cot gamma, right? Therefore, tan alpha is cot gamma, right? And so then I've got an equation here, right? So I kind of want to solve the equation. And so to do that, well, I need them both to be the same sort of function, right? So I need both to be tan or both to be cot. So usually I want to solve for tan, right? Because tan's a lot easier to work with than cot. And actually we know that cot is just 1 over tan. So we can say that tan alpha is 1 over tan gamma, right? And so therefore it makes things a slightly more clearer to see how we can solve now, because now they're both tans. But how am I going to deal with this 1 over tan gamma, right? I can't equate them just yet because it's 1 over tan. But hang on, didn't we prove something just very recently in the previous part? Didn't we show that 1 over tan alpha is tan of 90 minus alpha? Now that will apply for any angle, really. It doesn't have to just be alpha, right? It's an identity, really. It'll work for any angle. So it could just replace alpha with gamma, right? So 1 over tan gamma is 90 minus gamma. And now it's just a straight up tan. It's not 1 over tan, it's just tan. So we can replace 1 over tan gamma with tan 90 minus gamma. Okay. And now hopefully you can see we can now compare and equate the angles. So therefore alpha is 90 minus gamma. Okay. And there we are. Right, so I've got the angles then. But then how can I use that to describe the path of the ball? So sort of the direction of it, right? Now, this would be very, very tricky to see, right, if you haven't seen this sort of thing before. But think back to the common techniques I discussed at the start of this, right? And one of them was, especially when we got an angle, when we got angles like this, where we've got 90 take away the other one. What to help me visualize, to help me see what it will look like. Remember, we looked at the total angle deflection, right? Because remember, angle deflection is all to do with the direction of movement, right? Tells me how much I deflect by. So if I was to consider the total angle deflection, then, well, that's going to be the angle deflection for both the collisions combined. Now, I'm not going to go over that in too much detail. I went over that in many examples over the previous two videos. But the angle deflection essentially is going to be the two angles added together before and after. So in the case for the first collision, it's going to be alpha and beta, right? So it's alpha and beta. And then for the second angle deflection, for the second collision, well, again, it's going to be this before and the after angles added. Well, before it's 90 take away beta, then after it's gamma. So it's going to be 90 add beta add gamma, right? So 90 take away beta add gamma. And there we are. So that will simplify to, well, the betas were cancelled. So it's going to be 90 add alpha add gamma. But hang on, we know what alpha is. Is 90 take away gamma. So we can further simplify that to 90 add gamma add 90 take away gamma. And so you get a nice simple 180 degrees. And there we are. So what does that mean? So the total angle deflection is 180 degrees. That now tells me what the path will look like. So if the total angle deflection is 180, well, that's saying overall from start to finish, so before the collisions and after the collisions, I've turned 180 degrees. So what that would look like is if I initially look like that, right? So if I then turn 180 degrees, I'm gonna return back to that same sort of path, right? But in the opposite direction. Hopefully you can see that, right? So if I turn 180 degrees, I just move opposite, right? To where I was. Right? So that's what they're looking for. So therefore, the path of the ball is moving opposite to its original path. Okay. And there we are. So if I was to draw this on the graph, then right on this diagram here. So this was this is my initial velocity, right? That's the original path. So if I was to change the path at the end, it's going to then look like that. And so you can then see in that particular case, if we change the angle gamma, it would then be parallel and then it'd be in the opposite direction. That's essentially what would happen. Okay, but again, that's very, very nasty, especially for 1 mark, to realize that. But again, that's one of the standard techniques we looked at, right? Where we can consider the total angle deflection, especially when the angles are in this sort of way. And then you see the angle deflection goes to 180 degrees, and so it'll be moving opposite, okay, or parallel to the original direction. But yeah, very nasty question, right? But that's it for now. But I'll see you next time.